Hello, my dear children. Hope all of you are safe and sound at home. Happy to see you again. In the previous session, we had discussed about acceleration. And I am sure that you might have changed your concept about acceleration. Acceleration in physics doesn't mean going faster and faster, but it means any change in velocity. Any change, either increase or decrease in velocity, leads to acceleration. Today we will discuss some of the important numericals from this chapter. Also we will discuss graphical representation of motion. So let's get started with this session. Children, let's move on to the next question. This question is very important. It is there in your NCERT textbook. So, an athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What is the distance covered and displacement at the end of 2 minutes 20 seconds? So, this is the circular track and the diameter of the circular track is 200 meter. Athlete completes one round of the circular track within 40 seconds. And you are supposed to find out the distance and the displacement of the athlete at the end of 2 minutes 20 seconds. So first of all, let's find out the total time taken. So find out the time in seconds. Okay. So the time is 2 minutes 20 seconds. 2 minutes is how many seconds? Yes, 2 into 60 seconds plus 20 seconds more. 20 seconds. So 120 plus 20 equal to 140 seconds. This is the total time taken. So after 140 seconds, where is the athlete and how much distance he has covered? You are supposed to find out this. Now, to find out the distance, you must know the circumference of the circular track, because the distance covered by the athlete is equal to the circumference of the circular track. And you know the equation to find out circumference of the circular track. Okay, what is the equation for circumference of a circle? 2 pi r, right? Equal to 2 into pi, let it be pi itself, then r, radius of the track. Diameter is 200 meter. So radius will be half of 200. That means 100 meter. So 2 into 100, 200. 200 into pi. So this is the circumference of this circular track. Now, within 40 seconds, athlete completes one round of the circular track. It is given in the question. So one round means what? Circumference of the track. So this within 40 seconds athlete covers this much distance. Okay, so we can write distance covered in 40 seconds is equal to circumference of the track, that is 200 pi meter. So what will be the distance covered in 1 second? Distance covered in 1 second will be 200 pi by 40 meter. Right? Pure mathematics. Next, you must find out the distance covered in 2 minutes 20 seconds. That means 140 seconds. So, what will be the distance covered in 140 seconds? That will be equal to, distance covered in 1 second is 200 pi by 40. So, the distance covered in 140 seconds will be 140 into 200 pi by 40 meter. That is equal to 40 cancel. Then 200. Equal to 14 into 200 into, now you can substitute for pi. What is pi? 22 by 7, and also you have 4 in the denominator, so 4. Next, this 7, 14, cancel, 7 2s are 14, and again 4 5s are 20. So 4 into 50 is 200. Now what you will get? Children, as we discussed in our introductory video, let's start to solve the numericals of this chapter. Okay, this is going to be the first numerical of this chapter. What is the acceleration of the car that speeds up from 0 km per hour to 40 km per hour in 5 seconds? So here, the initial speed of the car is 0 km per hour and the final speed is 40 km per hour. So the first step in any numerical is to note down the data given in the question. So children, be ready with your pen and notebook and try to solve the numericals along with me, just as we do in our classroom situation. Okay, so first note down the initial speed of the car. Initially the car was at rest, that's why the speed is 0. So the initial velocity is denoted by symbol u. U is equal to 0. Since it is 0, I am not writing the unit along with that. Then finally the speed of the car increases from 0 to 40. So the final velocity v is 40 km per hour. Okay, hour. Then time is given in seconds. Time t is 5 seconds. So here time is in seconds but velocity is in kilometer per hour. So we need to convert this velocity from kilometer per hour to meter per second. And what is the step? Yes, multiply it with 5 by 18. So when you multiply it with 5 by 18, you will get the velocity in meter per second. And here 2 9s are 18. 2 into 20 is 40. So 20 into 5 becomes 100. 100 by 9. 100 by 9 meter per second. Okay, so this is our velocity, 100 by 9 meter per second. Now find out acceleration. What is the equation to find out acceleration? Acceleration A is equal to v minus u by t. What is v? V is 100 by 9, then minus u is 0. 0 divided by time is 5. So 100 by 9 minus 0 is 100 by 9 itself. 100 by 9 by 5. That means 9 and 5 will be in the denominator part. So you will get 100 by 45. And this is the magnitude. What is the unit of acceleration? Meter per second square. So what is the acceleration here? 100 by 45 meter per second square. And if you want, you can find out the fraction corresponding to decimal value corresponding to this fraction, 100 by 45. Let's move on to the next question. A car traveling at a speed of 30 meter per second slows to 5 meter per second in a time of 2 seconds. What is the acceleration of the car? So what is given? Initial velocity is given. Initial velocity u is 30 meter per second. Slows to 5 meter. So finally the car possesses a velocity, that means v is equal to 5 meter per second. Time is 2 seconds. Find out acceleration. Acceleration A is equal to v minus u by t equal to, what is v? V is 5 minus, what is u? 30 divided by time 20. And 5 minus 30 is minus 25 divided by 2. And minus 25 by 2 is minus 12.5. Unit is meter per second square. So here we got a negative value. Negative acceleration means what? Retardation. Why? Because the speed of the car has been decreased with respect to time. Children, this is the next numerical and I am planning to give this numerical as homework. So try to solve it by yourself. Pause the video for a while and note down the question. Here the car starts from rest. I will give you a hint. Starts from rest. So what will be the initial velocity of the car? Yes, it will be 0. And reaches a speed of 30 meter per second. So finally the car possesses a speed of 30 meter per second. So final velocity is 30. And in 1 minute. So time is given in minutes. But at the same time speed is given in meter per second. So convert this time 1 minute to 1 second. Sorry, convert time from minute to second. And how will you convert 1 minute to second? Yes, multiply it with 60. 1 minute is 60 seconds. Now you can easily find out the acceleration of the car using the equation a equal to v minus u by t. Here we have 2 into 50 into 22. 2 into 50 is 100. 100 into 22 is, so this is the distance covered by the athlete in 140 seconds. So one section of the question is over. We have found out the distance. Next, we must find out the displacement covered at the end of 140 seconds. So how to find out the displacement? For that, we must know where is the athlete after 140 seconds. So how many rounds the athlete will be able to complete within 140 seconds? That you must find out. So the number of laps or number of rounds completed by the athlete. Okay, number of laps by athlete. How will you find out the number of laps? Yes, how will you find out the number of laps? Just divide the total time taken by time taken to complete one round. So what is the total time taken? 140. Total time 140 seconds. And what is the time taken to complete one round? Yes, it is given in the question. Time taken to complete one round is 40 seconds, right? So the number of laps by athlete is 140. The total time by time taken to complete one round, that is 40. And when you divide and simplify, you will get 3.5. So the athlete completes 3.5 rounds. That means 3.5 rounds after 140 seconds. So after 3.5 rounds, where is that athlete? That you should find out. Here, suppose the athlete starts his journey from this point A. So after, see, this is one round. Again, this is second round. After, this is third round. So after third round, the athlete is still at the point A. He has completed 3.5 rounds. So after third round, athlete is at this point A, and after half round, where will be the athlete? So this is half round, right? This is half round. So after half round, athlete will be here at this point. So after 3.5 round, the athlete will be at the point B. Okay, children. So what is the displacement? Displacement is the shortest distance between initial and final points, right? So this is the initial point, this is the final point in this case. Because after 3.5 rounds, the athlete is at this point B. Then what is this distance? AB. AB is 200. That is diameter of the circular track, 200. So our displacement will be diameter of the track itself, and that is equal to 200 meter. Okay. So distance is 2200 meter and displacement is 200 meter.